Yeah, the topic is about automotive embedded software. Automotive embedded software is the backbone of the modern vehicles that enables the wide range of the functionality that enhance the performance, safety, comfort, and efficiency. It refers to the specialized software design to run on the embedded software system within the vehicle. Primarily, it have the electronic control units, the ECUs, which are to control and monitor the various functionalities that involved. As car evolved to become the smarter and more autonomous, automotive embedded software plays and increases the critical role in ensure the vehicle operates correctly and safely and efficiently. The agenda to understand about automotive embedded software, the overview, key features, architectures, and development process, what is involved, and the key standards, communication protocols, function domains, and challenges, what it will be involved, and tools and technologies, and what are the future trends that can be developed. The overview, the automotive embedded software is a specialized domain that focuses on developing the software for vehicle control unit, and it plays a critical role in vehicle operation and safety, performance, and user experience. And automotive embedded software, it refers to the code that runs on ECU in vehicle to control and monitor the various functions. The software is typically designed to work in real time and try to couple with the hardware. So with respect to the hardware and the software, we use to check the response and the performance. The overview key features, the real-time operation. So we need to ensure that timely it responds the external events which is triggered for critical safety features and the performance. And high reliable, it is developed to function under various conditions with minimum failures and functional safety. So compliance with standards of ISO 26262, we need to ensure that safety operations and resource constraints. We need to optimize the limited memory and processing power and energy. What is the architecture that involved for developing of the software? Here, the hardware layer we have should be the microcontroller, where it will plays a major role of decision making. It will be the core computing unit of the ECU at interface with the sensors and other communication protocols like CAN and LIN Ethernet, and power supply. It will be to perform specific controller. We require power supply to deliver the complete system. And the basic software layer, BSW, it includes the AUTOSAR architecture layer and other device drivers. Some of the protocols will be the CANs, communication stack like CAN, LIN, and diagnostic services will be included in the BSW layer software. Applications layer, it will be implemented specific vehicle functions such as engine control, ADAS features, infotainment, and the climate control. What will be the development process that involved for the automotive domain? Specifically, it follows the V model or Agile model, the process to ensure that the process makes the requirement to the deployment level. So initially the requirement analysis, whether we need to analyze the functional and non-functional requirements of how it will be defined. And examples like the inputs are the pedal position sensor data, and output based upon the pedal position, how the engine throttle will be adjusted. Based on that, we should design the system, high-level design of the system, include communication protocols and the software model or the interfaces. And implementation, we can be whether MATLAB Simulink or C++ code. And we should follow the MISRA C standards to ensure that compliance of the code it should follow some standards when we are implementing the code. And testing and validation. So once the code is involved for such designs, so we should validate the unit testing, integration testing, and system testing. And it should be tested on the tools, DSpace or Vector or ECU tested. We should ensure that the code is implemented for the specific requirements. What are the key standards to develop and test? The ISO 262, it talks about the functional safety for the road vehicle. AUTOSAR, it will be the standardized software architecture for automotive use. SPIC, it is a process improvement and capability determination model. Mr. C, it is the coding standard for safe and secure C programming in automotive application. CyberSecurity, it's defined the cybersecurity practice for automotive software to prevent the hacking risk. What are the key standards of ISO 26262 functional safety for road standards? The overview, it is the standard ensure that functional safety in automotive system focus on identifying and mitigating the risk from the hardware and software failures. Key elements involved here, the hazard and risk assessment. It identifies the potential hazards and classify them by the hazard here from A to D. It means A is low and D is high. Safety life cycle. It covers the entire product life cycle, concept and development and production and operation, decommissioning. System design. It enforces the redundancy and fault tolerance and file safe mechanism. Verification and validation. It includes the testing methods like hill testing, seal testing, and fault injection testing. Safety goal. It defines the measure to reduce the risk to acceptable level. Important, it's mandated for critical systems like ABS, ADAS, and ECUs. We need to ensure the reliability and minimize the risk in autonomous and connected vehicles. What are the standards that should be defined for the development process? So AUTOSAR and the SPIC standardization and process excellence. Here the AUTOSAR is the Automotive Open System Architecture. It is a specific software framework for ECUs in the vehicle. The key components it involved the BSW is the basic software that provides the hardware abstraction and services. And runtime environment it manages the communication between the software modules. Application software it implements the specific vehicle features and functions. Benefits is it is the reusability of the complaints across the different ECUs. It will be easier, and it reduces the development time and the cost, and ensure the compatibility between the ECUs. Specific to the OEMs and the suppliers when they are going to integrate it. And the key standards of the SPIC, automotive SPIC, it depends the process how the assessment model for the software and system engineers. It focuses on the mainly the capability and the improvement areas. It covers the requirement and design and implementation, testing and maintenance activity. The capability levels involves is level 6 levels, level 0, and level 5. Level 0, it talks about the incomplete, and level 5 it talks about the optimizing. The benefits here is we need to ensure the high quality deliverables and align the suppliers and the OEM process. It aid in meeting safety and performance standards. What are the communication protocols that needed for ECUs to communicate with respect to the embedded software, automotive embedded software? Automotive software, it relies on the robust communication to integrate the multiple ECUs. Common protocols include the CAN. It is used for real-time communication. CAN-FT, it is the extended version of the CAN with higher data rate. LIN, it is the low-cost protocol for non-critical safety. Ethernet is a high-speed communication for advanced feature like ADAS. FlexRay, it is for time-critical and fault tolerance application. What are the function areas of the automotive embedded software? Powertrain control, infotainment system, ADAS, Advanced Driver Assistance System, Vehicle Communication Network, Body Control System, Safety and Security System. Coming to the powertrain control model, the powertrain domain, it encompasses the system that generate and deliver the power to the wheels. You need to ensure that the performance and fuel efficiency and emission control will be a part of the powertrain model. Here it will manages the engine performance and fuel efficiency and exhaust emission and the transmission system. And specifically, it have the hybrid powertrains and the electric vehicle battery management. What are the key systems? So engine control unit, ECU, it will manages the air, fuel mixture and ignition timing and emission control. The example of this variable value timing, VVT, for the efficient combustion, and transmission control, it will be a part of the optimizing the gear shift based on the engine load and the vehicle speed. It will be for part of a dual clutch transmission or the gearless, seamless gear changes. The hybrid manages, it will manage the interconnection between the internal combustion engine and electric motor. And it specifically talks about the regenerative braking for energy recovery. And functional areas for the powertrain, it, it will be a part of the torque management for smooth acceleration, start and stop system for fuel efficiency, and exhaust gas recirculation for reduced emission. And coming to the other function domain, advanced driver assistance system, it improves the driving safety and convenience through the automation and monitoring and warning features. Mainly, the software for the safety systems like lane keeping assist, adaptive cruise control, automatic emergency braking, parking assist, and for autonomous driving features. And here the sensors are radar, lidar, camera, and some of the ultrasonic sensors are used for the automatic parking and collision avoidance and the emergency braking. Mainly some key features, adaptive cruise control. It maintains a safe distance from the vehicle head and uses the radar and lidar sensor to monitor the traffic. Lane keep assist, it detects the landmark via the camera and it gently steers the vehicle to safe within the lane. Automatic emergency brake, AB, it detects the obstacles and eliminate the collisions, applies the brake automatically to prevent and mitigate the accident. Blind spot detection, alerts the driver about the vehicles in the blind spot and uses the ultrasonic sensors of the camera to detect the blind spot detection. Parking assist uses the ultrasonic sensor to guide the parking maneuver. And advanced systems, it is a driver monitoring systems for detect the drones and distortions and traffic sign recognitions for speed and regulatory compliance. The other part of the functional domain talks about the infotainment. Infotainment system, it combines the entertainment, navigation, connectivity to enhance the in-cabin experience. And here the software for multimedia system and other part of Bluetooth, CarPlay, and Arduino Auto. So there are some other features involved for the infotainment features that to be developed. The key feature multimedia system, it talks about the audio and video playback from various sources, the radio, USB, and Bluetooth, integrated with the streaming services. Navigation system, it talks about the real-time GPS based on the navigation with the traffic updates. Features like route optimization, POI, point of interest. Connectivity, Bluetooth and Wi-Fi for the mobile device integration. CarPlay, Android Auto for seamless smart mode interaction. Telematics, it talks about the remote vehicle diagnostic and tracking, over the air updates for the software upgrades. The advanced features is the voice recognition for hands-free operation and integrate with the various assists like Alexa and Google Assistant. The chassis control system is the other part of auto domain where it involves the vehicle stability and handling and safety in various driving conditions. The key features involves anti-lock braking system. It prevents the wheel lock-up during the hard braking. It modulates the brake pressure based on the wheel speed sensor. And we have the electronic stability control, ESC. It talks about the enhancing the vehicle safely during the skidding or cornering. It applies the brake to the individual wheels and where the vehicle can be stopped automatically during the certain speed. It can be not able to control. And due to that, the traction control system will play major role. It will limit the wheel spill during the acceleration or slippery surfaces. It works in conjunction with the ABS and ESC. Functional features is the hill start assist for preventing the rollback on the slopes, and dynamic steering assist for optimizing and steering the effort. And the other domain part is the body electronics. Body electronics talks about the comfort and convenience features for the user experience. It manages the non-critical but important vehicle features like lighting, wiper, windows, seat, and HVAC, heat, ventilation, and air conditioning. It manages the non-powertrain features, and it will play major role for the key systems like light man system, adaptive headlight that adjusts the beam direction based on the steering input, and daytime running lights for visibility enhance, and wiper system during the rain sensing wipe that adjusts the speed based on the rain intensity. And the climate control, it will be automatic temperature regulation through the sensors and the actuators, dual zone and tri-zone and quad zone. There are some of the features. It will be the climate control for personalized comfort, and additional features, power windows and sunroof with anti-pitch functions, and central locking and keyless entry systems. What are the challenges involved? It will be the integration complexity, where it will managing the interaction among the multiple issues. Safety and security, it will ensure the protection and against the hardware failures and cyber security threats. Scalability, it support the future upgrades and additional features. Runtime constraints, it meeting the critical strict timing requirements for critical applications. What are the tools and technologies involved? The development, it will be the IDE, Keel, and Eclipse, and compiler GCC, IEC, and debuggers JTAG and Lauterbach, and some part of simulations and testing, the hill testing, GSpace and NI. There are some other benches can be used, and protocol testing, CANOE, CAN Analyzer, model-based development like MATLAB Simulink, and version control like Git and SVN for the managing the code-based. And what are the future trends that involve? Software-defined vehicles, SDVs. So it will be the centralized computing platform, replaces the distribution ECUs, and over-the-air updates. It regulates the software updates for enhancing features and bug fixes, and artificial intelligence used in autonomous driving and predictive maintenance, and cybersecurity. It increases the emphasis the protective vehicle from the external threats. What are the key players in automotive embedded software? There are some of the organizations which involve for developing the software to the specific OEMs. Automotive suppliers here is Continental, Bosch, Denso, and Magneti Merlin. These are the some of the examples of the organization. They work on different features, and some of the semiconductor companies like NXP, ST, Microcontroller Electronics, and Renesas, and Texas Instrument, and supplying of the OS and other platform developers like BlackBerry and WinRivers and Metro Graphite, and some of the software platform providers, AutoTrucks and Electrobits and Vector Tools, and specialized tech companies like Mobili, Intel, and Velodyne Lidar, NVIDIA. So these are the some of the key players in automotive embedded software.